Let's start with the objectives of this tutorial. Interference of light is when two light rays from a coherent source meet together. In this, there is an energy dispersal of one light wave due to another light wave. This disturbance causes a tempering, superimposition of the light energies. Let us go through the interference of light examples. Interference in incandescent bulbs. Interference is seen in a butterfly. Interference of light example as a bubble of soap. Interference seen in patterns formed on roads. Interference in an anti-reflective coating. Interference on an oily surface. Interference causes hologram. Interference in incandescent bulbs. For interference to take place, there are two conditions that are necessary. Firstly, the two light sources used must be coherent, which means that the two light waves must have a constant phase among themselves. Secondly, the light waves must be of a single wavelength, and lastly, the principle of superimposition must be implied. Now for an incandescent bulb, for interference to occur, all the conditions mentioned above should be facilitated. But as we know, two identical bulbs cannot produce light waves in the same phase or frequencies. The light bulb produces light waves which are non-coherent. This tells us that the photons of light emitted have a frequency randomly related to any other photons emitted from the same light bulb. Hence, for interference to occur in the incandescent light bulb, the source of the two light waves must be the same. The two light waves photon have one pair of the photon to cause interference. However, only two identical lasers having highly stabilized frequencies can produce a visible interference pattern on surfaces. Interference is seen in a butterfly. A species of butterfly known as the blue morpho butterfly shows interference in our day-to-day life. This butterfly species is naturally found in tropical and subtropical regions of Latin America. It is surprising to know that irrespective of other organisms found, the blue color of the butterfly is due to the phenomena of interference, not due to natural color. The blue color in the wings is caused when the light falls on the wings of blue morpho, which are made up of very nano components. Then the blue color component in the light goes through constructive interference, whereas another color spectrum follows destructive interference. Due to this, the bright blue color is visible to the observer. Interference of light example as a bubble of soap. The soap bubble is also an example of interference of light. Let us see how. The soap bubbles formed by a soap solution, which is spherical and very thin, shows interference as when the light rays fall on the thin film of the bubble, the light gets reflected from the top and bottom underlining of a bubble. During this, some selected colors only undergo constructive interference, while the rest undergo destructive interference. Due to the former type of interference, only the colors are visible. At the same time, later one does not cause any visible light. Interference saw in patterns formed on roads. We have often seen full-color patterns on the road during a rainy season. This is an example of interference. Due to some oily substance scattered on road or, say, an oil spill in the ocean or sea, an oily layer floats upon it, causing interference. As when the white light falls on them, they reflect. The reflection is from the top surface as well as the inner layer too. When the light ray strikes, it undergoes interference mainly due to the oily layer. Due to the presence of oily layer on roads or sea, when light strikes, undergo constructive interference and destructive interference. Some of the light colors going through constructive interference cause the visible light pattern, whereas the light color under destructive interference are not visible. Interference in an anti-reflective coating. In our daily life, we commonly use specs. We very commonly find colors visible when light falls on our lens and specs. This happens because of interference. As all such apparatus have a reflective coating on its surface. However, the reflective coating on the lenses, camera, etc., are provided to reduce the intensity of light falling on it. The formation of color pattern on such apparat is due to the constructive interference of light on the top and bottom surfaces. Interference on an oily surface. We all know that oil and water can be mixed. This happens because of the different properties of the two fluids, as the two fluids have different densities, which leads to not letting them mix. And consequently, we can see an oily layer of oil floating on the top of the water. When a ray of light strikes the oily layer, in such a condition, the light gets reflected from both the top and bottom layer of oily floating. Due to this, the colors present in the light rays undergo interference, both constructive and destructive. Due to constructive interference, only we see different colors pattern on an oily film floating on the water surface. Interference causes hologram. A hologram is an artificial 3D picture, which can be easily differentiated from a flat picture or a flat surface. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.